Welcome back. In this lesson, we're going to take an overview of how the internet works and how different locations on the internet are defined. We'll look at the physical structure of the internet, the protocols that underpin the working of the internet, how every location in the internet has its own address, and how this enables us to define web pages. The internet has an underlying physical structure. This is a mesh network. That means a network where there are multiple routes through the system. At a deep level, the internet is composed of a series of transcontinental cables which go on the ocean floor and join the continents together. Different countries have national internet service providers, and these connect the countries to these large international cables. So here's a quick photo of some of the main cables and where they go. The biggest go through the Atlantic and Pacific Ocean. However, the physical structure on its own isn't enough. The internet works as an international universal system because all the different computers that work with the internet use the same communication standards and protocols. Some of those standards, such as Wi-Fi or Unicode, are regulated by organizations. They don't have any legal standing, but devices that can work with those standards are given certification, and in practice nobody wants to buy devices unless they can connect to the internet and talk to other devices. So all the devices you own will use these communication standards. There is a further protocol called IP, which stands for Internet Protocols, and together with TCP it makes the internet work. Every device that is connected to the internet has an IP address defined by the Internet Protocol, and it consists of 4 numbers from 0 to 255. There's a URL on the board, and you can use it to find your IP address, and I've given an example below. So if you want to go to that website and find the IP address of the device that you're using to watch this video, you can do that now or at the end of the video. And then every device has its MAC address. MAC stands for Media Access Control. So for example, if you're in a college, the main college server will have an IP address, and then every computer and Wi-Fi enabled device within the college will have an additional MAC address which identifies the individual piece of hardware. So add the MAC address to the IP address, and that gives a complete unique definition for each computer, tablet, phone, or whatever in the college. And you can find your MAC address by viewing the network properties of your computer, for example, through Windows settings. So I've just shown you an example there. The World Wide Web is not the same thing as the internet. The World Wide Web is all the websites in the world. The internet dates back to the 1960s, whereas the World Wide Web was created at the very end of the 80s, beginning of the 90s. But we can look at websites by using the internet, by using internet protocols. So many people use the two terms interchangeably. Every resource on the internet, for example, a web page, has got a uniform resource locator. That's like the address of the resource. So we've talked about the IP address of a device, but a URL identifies a resource such as a website or web page. How do web pages, websites get these addresses? Well, there's a great big organization called the Internet Corporation for Assigned Names and Numbers, but that's really, it would be a huge job to have to define that for the whole world. So they have delegated that responsibility to big bodies called internet registries, and those are the main 5 internet registries. So they control vast areas, and you can apply to them to get a to get a resource definition. You often do it if you use a service that lets you set up a web page. They will have an arrangement to get you the IP address. So the IP address is a number, and the URL is a set of text that identifies a resource. And if you connect the URL to the IP address, that means that if somebody types in the URL of your web page, they will connect to the page on your device, let's say your internet server or your web hosting service. Of course, these URLs are not just given out at random. There's another organization. The domain name system is set up so that you can give people or organizations web page addresses, and it's they work like this. There's further domains, for instance, .co.uk, and then the full domain name will tell you who hosts the web resource. So you'll recognize that web pages and websites end with that kind of text, and those are different levels of domain. The host name often begins with a short string that tells you what type of resource it is, and web pages often begin www. Our college Keck doesn't use that, so it's not compulsory, but you'll often see www at the start of a web page address. And even right at the very start, you'll see the protocol that's used by the page. HTTP is very common. That stands for Hypertext Transfer Protocol. That's what lets you load the web page. Or you might see HTTPS, which is the same protocol but with extra security features on. And you may see a little picture of a lock at the start of the URL to tell you that the page is secure. Just a bit of advice, I would never give personal details, and particularly anything to do with money, to a website unless it uses secure protocol. So look out for that. And at the end of the web address, you might see a / and then a page name. So in this example, BBC /news, so it's the news page of the BBC website, and the hashtag can direct you to a bookmark within that page, for example, the latest news. So here's an example of a URL. The protocol is HTTP. The top level domain is .co.uk. Second and third level domains bbc.co.uk, and the host name tells you is completed with www to show you that it's World Wide Web, and the individual page is the news page. So a URL's got a lot of information in it. And as well as web pages, be aware that there's something called the Internet of things, and this is where things like devices can also connect to the internet. So you could send a message to your central heating to switch on. Let's say you're out and you're worried that your pipes will get frozen. If your internet is connected to your central heating, you can switch it on, or check if you need to buy more milk. There's all kinds of things set up nowadays through the Internet of Things. So if you're my student, there's a worksheet on this, and if you're not my student, then it would be a good idea to continue your research into how the internet works. Okay, next lesson we're going to look at the protocols in a bit more depth. So bye for now.